Good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to give you another code review. This code review is going to be on a binary classification data set, being the Titanic data set. And I know that the last code review I gave you was a binary classification data set, but that was using sklearn's toy data set, and it was converting the data set onto a NumPy array or a JAX array. But what I wanted to do in this instance is I wanted to use a CSV file and use pandas to convert it to a data frame, and then from the data frame then we'll convert it to a JAX array. So that's what I wanted to do in this particular data set, because I want you to know that there's different ways you can download a data set. The last data set was just a toy data set from sklearn, and it was very easy to do. This data set is a little bit more difficult because it's a CSV file, and you're gonna have to use pandas. So what I'm going to do is, let's just look and see something. This is JAX Titanic. Okay. So what I'm going to do is, I did the program in Google Colab, which is a free online Jupyter notebook. And Google Colab is a great platform to use to convert to code in Python, but the problem is it doesn't really have an undo function, and because it doesn't have an undo function, you have to be careful not to accidentally overwrite or delete any code. But if you do happen to do that, then you can come over here into the save history, and you might be able to retrieve the code from the save history, but you can't always do it. So that's why you need to be careful not to delete or overwrite code. So after I've created my program in Python, the first thing you want to do is you want to import the libraries. So you're going to import pandas as PD, which is a data processing library, and it converts your CSV files to data frames. You're going to import JAX, which is going to create your neural network that we're going to use. We're going to import sklearn to provide machine learning functionality, and in this particular instance it's going to be train test split, and we're going to import matplotlib to visualize the data. So after we have imported the libraries, what we're going to do is we're going to use pandas to read the CSV file and convert it to a data frame. And this data frame is called data. Then what we're going to do is we're going to convert the commas to full stops, because this data frame that I acquired must have been like European, and in Europe they use commas instead of full stops. So we're going to replace the commas with full stops. We're going to impute the null values for age, and we're going to do it a little bit differently because it's going to be broken down between children and adult. So if it's an adult that needs to be imputed, it's going to be the median of the age, and if it's a child that's going to be imputed, it's going to be 9. So I just put that in the middle between 0 and 18 and made it 9. So that's what we've done. We've imputed the values for age. Now what we're going to do is we're going to impute the values for fair, and when we impute the values for fair, we're going to use the mode, and that's going to be the most commonly used value. So that's how we impute the values for fair. So we're going to convert the object to a float in the age in the fair column. So data.age equals data.age.as type float. Data.fair equals data.fair.as type float. And then you can see that we've converted the age in the fair to floats. Now we're going to round age in fair, and how I rounded it was I rounded it just converting it to an integer, but you could also use the round function if you wanted to use the round function and play around with that. Now we're going to convert the age and the sex to a float. So if the sex is female, it's a 1. If it's a male, it's a 0. On the age, if it's adult, it's a 1. It's a child, it's a 0. And then so those are dictionaries. So data sex dot replace sex tick in place equals true. Data age B replace data age in place equals true. So now the values are going to be either 0 or 1. So we're going to drop the ID. You don't need the ID in this instance, and the reason why is because Pandas automatically indexes each row of data. So you don't need the ID. Now we're going to visualize the data just to give you an idea, just to visualize it, to make it a little bit more pleasant to look at. So the greens are the people who survived, and the reds are the people who perished. And so it looks to me like it's got more reds than greens, which was obvious because more people perished than survived. Now we're going to define our x and our y variables. So y equals data survived, x equals data dot drop survived, axis equals 1. And then so you can print the shape of the x and the y. And now we're going to check info for x, and you can see all of the columns of data or all of the features are integers, which we want. We're going to standardize x. And we're going to do this in JAX. So mean equals JNP dot mean, x dot values, axis equals 0, std dot dev underscore dev equals JNP dot stt, x dot values, axis equals 0. So x equals x minus mean over std dev, and that's your standardization. And so when you standardize it, the mean is going to be 0 and the variance is going to be 1. And we can look here. Okay. So it says right here that the mean is 0 and variance is 1. So what we can do just mean equals 0, variance equals 1. So the next thing we're going to do is we're going to convert the x and y variables to JAX arrays. So x equals JNP dot as array x, y equals JNP dot as array y, and then you print the shape. And now we're going to use sklearn's train test split function to split the x and y variables into training and testing data sets. So that's what we've done. So you've got x train, x test, y test equals train test split, x, y, test size equals 0.2, shuffle equals true, random state equals 42. And then you can see the shape. You always want to look at the shape. Now what we're going to do is we're going to define a neural network. So our neural network, we have to define our functions. And then your sigmoid is going to create an S, which is going to be from 0 to 1. So the bottom is going to be 0 and the top is going to be 1. And the sigmoid derivative is going to create a normal distribution at the middle of the sigmoid curve. So you can just say here, sigmoid derivative, machine learning. So you can see here, here's some pictures. There's one on Stack Overflow. So the blue is the sigmoid where it makes the S curve, and the sigmoid derivative is at the middle of the S curve. So you can see that the formula, the form that it takes. So that's the best way to say that. Okay, so after we define our formulas, then what we're going to do is we're going to define the neural network architecture, and then a neural network is got the input neurons, hidden neurons, and output neurons. So we can say that. So you can see that. So you can see here's something from Wikipedia. Here's your input, which has three features. Here's your hidden, which is going to be the number of features that you want. Here's your output. So this output is pretty much a softmax because it has two outputs. But what we want to look at here is we want to look at one that has one output, one neuron as an output,
suggested